In this video presented by www.free-academy.com, we're going to continue our practice of the trigonometric derivatives by doing problems 5 and 6 out of the text. Now we have problem 5 up here. We'll tackle problem 6 after we get done with it. Problem 5 says f of x equals x to the third times sine of x minus 5 cosine of x. And we need to find the derivative of f of x. Now, the trig derivatives are fairly straightforward in that we have all the formulas over here, but we need to get them to a point where we can take the derivative of them. Now, if you take a look at this first part here, we have x to the third times sine of x. This is just begging for us to do the product rule on it, with f equaling x to the third and g equaling sine of x. And recall the product rule is that if you have the derivative of f times g, it's equal to f prime g plus g prime f. So the derivative of x to the third is 3x squared, and that'll be times g, which is sine of x. And this will be plus f times g prime. G prime is the derivative of sine of x, which we have written over here, is equal to cosine of x. So there's the derivative of our first term, and this is going to be minus 5 times the derivative of cosine of x. Because remember, the constants always come outside the derivative. The derivative of cosine of x is equal to negative sine of x. So we'll apply the negative sine of x. And there we have the first derivative of problem 5. Now let's go on and do problem 6. Where we have the derivative of f of x is equal to cosine of x divided by x sine of x. Now this problem, there's a couple ways of going about it. The favorite one, I think, is going to be to split this function up into 1 over x times cosine divided by sine of x, which you can then split up further to 1 over x times the cotangent of x. And now this gives you a relatively straightforward problem comparatively speaking, because we are able to do the product rule on both of these pretty easy. So we have f is equal to x to the negative 1, so the derivative of f prime is going to equal negative x to the negative 2. G is equal to cotangent of x. And g prime is the derivative of cotangent of x, which is negative cosecant squared of x. So now we do our product rule, f prime g plus g prime f. And our first derivative is going to equal negative x to the negative 2 times g. This will be plus g prime, which is negative cosecant squared x, times f, which is x to the negative 1. Now I would like to write my x's out front of any trig. So let's rearrange this, and we get x to the negative 1. And there we have a straightforward way of doing this problem. However, that's not the only way of doing this. We can also do this by using the quotient rule. So let's do that and see what it gives us. Quotient rule is f over g. So f is equal to the cosine of x. F prime is equal to the derivative of cosine of x, which is negative sine of x. G is equal to x sine of x. G prime, this is going to be doing the product rule again, and I'm not going to go through this in huge detail because we've done this a couple times in this lecture already, but it's f prime times g, derivative of x is 1, plus f times g prime, which is derivative of sine of x, cosine of x. And our formula for the derivative, the quotient rule, f over g, is equal to g f prime minus f g prime over g squared. So using the quotient rule, our derivative f prime of x is going to be equal to g x sine x times f prime, which is negative sine of x. So we'll apply the negative, square it. This will be minus f times g prime, which is sine of x times cosine of x, or x cosine of x. And this will be divided by g squared, which is x squared sine squared x. So that is our derivative using the quotient rule. Now I'm not going to go into this in any deep mathematics. However, if you were to simplify this expression, that you can show that the two are equivalent. And I'm not going to do this in this lecture, but I'll get you started just in case you want to do this exercise as practice. The first thing I would recommend is distributing out the cosine term, and then noticing you have an x sine squared x minus x cosine squared x, which you can factor out the x to get sine squared plus cosine squared. In the numerator, and then this would also be, well, either way, your entire numerator would be equal to sine x cosine x. So you can simplify the numerator into this term, and then if you do a little bit more algebra on it, you can show that the two expressions are equivalent. So we're not going to go into that exercise, just going to keep on and doing some more practice problems for you guys.